But anyway, we got it with GNOME. So help of GNOME. Thanks, GNOME, for that. So today we will be seeing about the container registry. How many of you use container registries? A lot of hands. So if you use Kubernetes and you don't use container registry, then you are lying to me. So yeah, okay. Let's start with about me. I am one of the contributors of Harbor. How many of you know Harbor? Okay, a lot of hands. So Harbor is one of the container registries, just like Docker Hub, but you can self-host it and then configure it a lot, and then use it in your platforms, pipelines, everything, and also it can run on your local system too. So I work in the company called 8 Years, which make SaaS product around the Harbor Container Registry. And then I'm also one of the mentors of Linux Foundation mentorship. So I mentor people there, help them get into CNCF ecosystem, learn the ecosystem, and then get back to the community. And yeah, just growing the community. To know more about me, scan the QR code so you can get all of my links around me, maybe at the last. So let's talk about this. Maybe not about this, but maybe about this. Maybe not. Maybe let's just talk about this, okay? So this is much easier. Instead of pretty big, huge landscape of 1,000 projects, I don't know, maybe more. I think 1,300, even more. Some are still in PRs, and so it will be accepted. So let's see like a brief history. You can scan this QR code to get the stories and the details about how Harbor got started, and then how it got into CNCF, and then how it's now run by the community. So Harbor got started in 2015. Like it was starting along with the Kubernetes, while the Kubernetes was starting up, and then Harbor was like in the internal platform of VMware. Harbor comes from VMware, but now it's currently under CNCF, and CNCF hosts Harbor, and it's now a graduated project. So let's see. So let's talk about what Harbor provides. It out of the box, it provides role-based authentication, so you can give roles across your enterprise users. This is a container registry that is created by an enterprise to serve an enterprise purposes. So it has role-based authentication and authorization, and also replication and proxy caching and compliance, multi-tenancy, and robot accounts. We will go through all of these topics one by one in the upcoming slides. And also, there is even more. Like replication policies are used for image synchronization, and Harbor comes with custom vulnerability scanners that scan your containers just out of the box. You need to install Harbor and set it up in your Kubernetes cluster. And once you set it up, just try to push an image to Harbor using Docker push. Once you do it, there will be an option to scan the container you just pushed. So it will find the vulnerabilities in the container without you specifying anything. And you can also make it auto. So every time you push an image, it will go through the scan pipeline, and it will be scanned, and you will be reported of all the vulnerabilities through a webhook, or you can set it up all of those things. You can get a Slack notification, or you can get an email. So there's a lot of configuration options over that. And also authentication with LDAP. How many of you know LDAP here? Okay, that's a lot. I thought maybe nobody knows LDAP. Okay, maybe you guys are, yeah, maybe you guys are well with the enterprise, but people who are not with the enterprise doesn't know LDAP. So LDAP is as an authentication thing. It's also started from Microsoft Active Directory. So Active Directory is how you manage users, the role-based authentication things in a directory structure, which is not good, but works for the enterprise. So, and also we support OADC, so you can use different OADC connections and then onboard users via that. Also, we offer garbage collection. So how many of you know what is garbage collection? Like just the term. Can anyone say it? Let's keep the session interactive, not like me speaking out and you just listening. Yeah.
Clearing out unused objects.
Mm-hmm.
Clearing out unused objects.
Yeah. So what do you think a registry with garbage collection do? Any ideas?
Overriding the unused layers.
Mm-hmm. Override?
Overriding the unused layers.
Yeah, kind of. Any other ideas? Anyone? Just say it out loud. Mm-hmm. Yeah, removing duplicate layers. But in the first place, duplicate layers will not even happen because of distribution. So people who don't know distribution is the underlying thing of all the container registries that are out there. So it is previously was called as Docker distribution, and it is also the underlying thing that runs the Docker Hub. So yeah. We will see more about the garbage collection, but let me give you a gist about that. So what garbage collection is. So garbage collection in Harbor is an asynchronous task that you assign. So what it's going to do is, like, it's going to find the tags that have been deleted. So, so people think in Harbor, you go to registry and then click on image and then delete it. So you are not actually deleting it. So it's just a soft delete, and it's marked as deleted in the database and not actually deleted, and the layers are still present in the storage. So if you delete an image worth of 20 gigs of size and then go to see your storage or any S3 bucket, things like that, and then you still see your storage has not been recovered, so yeah, that might be the thing. And you need to run the garbage collection to get rid of that unreferenced layers. So more on layers and what's the layers about and all of those things coming up. And there's even more features in Harbor. So one is SBOM. How many people know SBOM or haven't heard of it? So anyone can give me a quick gist of what is SBOM? Software bill of materials. That's the right answer. So why do you think it's used?
Basically, we can get to know the different packages like
Mm-hmm.
this that made up that particular product.
Yes.
If you take iPhone has so many components.
Mm-hmm, mm-hmm.
Bill of material concept from manufacturing.
Yes.
That is applicable to software also.
Yeah. This came from the manufacturing things where they have a bill of all materials that have been used in the making of a car or anything. So it will be even put simpler. Like if you buy a juice packet, you can see the ingredients. So that's an equivalent to the SBOM. Like what are the ingredients and how much of the proportions they are used. So why does SBOM? We can do a great talk about it, like SBOM and this compliance and then all of those things. But short answer, SBOM is a software bill of materials that not only shows the bill of materials that are directly dependent on your thing you created, but also you have indirect dependencies, like the dependencies of the dependencies, right? So those dependencies will be captured by SBOM, and then signing. So this is used to sign the artifacts that you produced, the images that you produced. You can sign them and enforce policies and things like that. So those are there. So, and you have seen, I mentioned robot accounts, but you don't know why robot accounts. So let me show you why in Harbor we don't have tokens. So we have robot accounts. Tokens come with a major problem, like if you have an user and then user generates a token and then the user gets kicked off from the enterprise, then the token generated by the user stays alive for the expiration time of the user. So that token is still valid. Like an user gets removed from the organization and he created a 6 months user token and he got removed in 3 months, and for the next 3 months the token is alive and it can be used to access your internal things. And there is no way, unless you have like some ridiculous database schemas, you can't get the token back or revoke it because the user who actually created the token are already deleted. So there is no reference to it, but the token is still valid. So yeah. Okay. So robot accounts fix this by instead of users creating these tokens, they create robot accounts. So these robot accounts will serve as a minimal point of contact, like minimal permissions, like you can give, okay, this project, then you can read this image. I will show you a quick demo, like after that you might get the whole picture. So for now, let's take it. So before going under the hood, because GitHub is not working here, going under the hood requires a lot of GitHub and a lot of code. So we can't do the part, but I will show you a quick demo of Harbor and how Harbor works. So we can do that. Okay, finally. I thought Harbor might not work, but still good. Yeah, good to see Harbor. Okay. So this instance is located in demo.goharbor.io. Like this is a community instance provided by Harbor. So this is an open source instance, and anybody from the community can use it. Like if you are an user, or if you want to figure out like how Harbor feels, but you don't want to take the risk of deploying or like setting up all these YAMLs and figuring out stuff, you can just go to the instance and get a feel first, then actually deep dive into the thing. So let's do that.
What's the
Credential is open and it's in documentation.
No, right now what you're using to log in? I mean, no. Is it your account or it's a public account?
It's a public account.
So, I'm sharing the screen, so if you can tell me.
Yeah, so it's harbor-cli and then harbor12345. That's the password. So it's a public and anyone can access it. And also you no need to access this specific thing, but in Harbor we have created one of the best things, which is people can onboard themselves. So one sec. Okay, the scroll is okay. When we zoom out, we can see sign up for an account under the login button. Here you can click and then give all of your details and then create an account for you. And you will get the admin permissions. So use it wisely.
Okay. Coming to password, can you show the password what you're doing?
But this is public. You can.
It's capital. It's capital.
Yeah. It's fine. Unless you don't delete all the images, it's fine. Because
No, because I'm sharing. You're having.
yeah. Okay. Yeah. Okay. Good then. So this is the first interface you get with Harbor, which is like a lot of different options on all the sites. Like you have a lot of administration options. You have all of these different projects, and also there is a event log button down there, which have events there, and then you have the quotas, you have the repositories, you have the total number of projects, all of those things, and you have different things. Let's remove this first. So now let's see. Okay, let's start from projects. So each project will have its own view, and you can assign users to specific projects. So how you can do that is going to the members, then you can assign users based on their roles. This is the role-based thing, which you can see. You can assign users based on their roles and then give permissions, like they can only view, they can only push. Like for example, developer can push and pull, but he can't change the configuration. for example, maintainer can do all of it, and project admin can delete the project itself. So yeah, pretty much simple. So and you also get logs. This is for audit logs, like what are the events that are happening in the registry. Then the good part is the administration. So you can onboard users and manage it, pretty much easy. So this is the cool part, which is robot accounts. So robot accounts, you can create robot accounts, assigning them to specific projects. The good thing is you can assign them to the specific project, but you can also give specific permissions, such as this robot account can only read. Let me show. Okay. So for example, the robot account we took is SAABC, and this robot account is assigned to the project Satellite and BusyBox. And this robot account has 3 permissions to the satellite project, and which of these are artifact read, and then repository pull and read. So this robot account, if you use this robot account in the CI, and you don't need to worry about the security, because even this robot account gets leaked into your CI or something happens, this robot account can only read the specific project that you selected. But if you go with other registries or other container registries, they don't have this specific features. But yeah, that's how robot accounts is better than tokens. So yeah. Okay, next. Okay, we see the robot accounts. Now let's create one robot account for now. Okay, robot. Okay, let's set it to never, so it won't remove itself. And also you see the system level permissions, like you can either go and read, select every different options, or just select all, move on, and give all the projects all the permissions, then shoot yourself in the foot. Yeah. So, and then you get the robot account secret. So this secret is only valid once. Like after you copy the secret, we don't store it in the Harbor database. It's gonna be gone forever. So it's your good time to copy this, copy it and keep it safe. Yeah. So the good thing is, if some robot account get compromised, you can easily go and hit refresh secret, and then refresh it. So now you create a new secret. So yeah, you still use the robot account, but with a different secret. So these things, and the another best part is the ability to add multiple different registries. So let me show you. So we can create an registry endpoint. So why adding multiple different registries? So the thing is, people think container registry as a central hub. So you push and pull all the images there, but you don't think about more into the container registry itself. So what I mean by this is, container registries can do more than you think. For example, creating and managing robot accounts is one, and being able to act as a backup registry, and also being able to act as a proxy registry, and also being able to act as a central registry which manages all the backups, and also able to distribute container images across multiple different registries and clouds. So let me show that. So we have a long list of registry supports, starting from Alibaba, AWS, and to Tencent, Harbor, GitHub, everything. So you can choose any registry you want, and then create an registry endpoint, which you give an endpoint URL and access parameters. Once you've done this, you have a registry. So using this registry, you can do replications. So what are replications? So replication is something. So I said you can use this Harbor as a central registry that can push images to other registries. You can do that by creating a replication policies, also known as replication rules. So you create a name, for example, let's put in something. So we set a resource filter. This resource filter is just by regex. So you set what are the different projects you want to replicate from one registry to other registry. Then you set all of these parameters, fill it out, set the destination registry. So for example, Docker Hub. So for example, if you have a registry like you want to push images to prod, but you need them to pass the scanning and the vulnerabilities. You can do this with the help of replication. So yeah, that's one thing. And then there's distribution, and then which also does the same thing, but with Dragonfly and different registries, but we don't want to go then because it might get even more lengthier. Yeah. So and you can also set project quotas based on each project. So this is where the multi-tenancy support of Harbor kicks in. So you can not only have a central Harbor registry, but you can give it to other users and then ask them to use these projects and then give them permissions to the project only so that they can access that. So, and then this is the garbage collection I mentioned, so which will do weekly cleanup of your registry, like unreferenced tags and then deleted images will be removed, and you can see the number of jobs that are currently running. Currently, there's no jobs running, so yeah, you can see it here, and then yeah, that's pretty much it. So, yep. I think you know most of the Harbor now, so yeah, good luck. Let's now go under the hood of registry and know how containers are made and how registries store containers. How many of you know how containers under the hood? Okay, one, right? 2 hands, good. So can I get an answer? Namespaces? That's a bit vague. Yeah. Yeah, that's one thing. But we are talking in terms of registry. We should not go into the runtime spec. So there are multiple different spec. So there's a runtime spec, there's an OCI spec, and there's a distribution spec. So distribution spec is the one we talked about, the registry I showed you. That follows the distribution spec, which means any container that is pushed to the registry should not duplicate itself. And in the distribution spec, it's stated clear that layers are the first-class citizens. Like each layer will be its own, for example, like every layer will only be created once. So there is no duplication. If you reference a layer again, like if you push 20 gigs of image, but the base layer that you set, like Ubuntu or Java or Node, is the same, then you don't make this network call and push the layer again, but you reference it and then push the other layers that are not in the registry. So that's one thing. That's how the registries store containers. So this is the overview of the container for the registry. Like for the Docker runtime spec, that is different because it comes with a lot of different things like the inspect command, the health command, and then the run command, all of those things. But for the registry looks the containers as this, like it gets the index.json, which contains what are the manifest and what is the config. So it will point to the manifest, and the manifest point to the config, which is all of these are stored as a layers. Let me show you what a layer actually is. So, and this is the Harbor architecture. Let me do this, and then let's come with that. Nope. Yep. So one sec. I have created a project for specifically for this use case. It's hosted on GitHub. You can get it. The GitHub is -v. So it's in GitHub bub OCI spec implementation. You can go there yourself, get the project, so we can be on the same track. So yeah, let's do this. Okay, so we have the model. So for now, I'm just. How many of you know there's a time's up? Okay. So yeah, there's a GitHub project. Go there, explore yourself, and I will be showing how the containers implemented. So yeah, and there's a good README I put there. So these are the steps that you can just make sure you have ORAS, Crane, and an OCI compliant registry to make this work out. And then you can create your own container by just following this README, and then you're good to go. So yeah. Okay. Let's go here. Yeah. So this is the overall hub architecture, like what are the different components in it, and this is the registry model. We talked about the registry, the different tags which referencing the index, and then index referencing the manifest, and the manifest referencing the blobs. So blobs are the final part, which is also called as layers. So everything stored in a registry is a layer. So that's the final point you need to take to home. And these are the links that you can check out. And thank you for your time. Yeah. Okay. Any questions?